Okay, so last time we got done up to problem number 72. So let me do problem number 73. F of x is equal to x plus 2 quantity squared plus 3. Sketch the graph of the quadratic function using transformations. So show at least 3 points on your graph. Give the vertex and axis of symmetry. Okay, so let me write this as y is equal to x plus 2 squared plus 3. Let me subtract 3 from both sides of my equation. And so this just looks like y minus 3 equals x plus 2 quantity squared. And so this is just the following transformation is just a translation of y equals, oops, it's a translation of y equal x squared, and it's going to be 2 in the negative x direction, so 2 to the left, oops, and 3 in the positive y direction, and so and up 3. So let's do that. So let's graph this. And so let's do 1, 2, 2, 3, 4, 5, 6. So I just put my tick marks on the x and y axes. And so let me sketch the graph of y equal x squared. So it should look something like this. So this is a graph of y equal x squared. And I want to move this up 3 and to the left 2. Okay, so I'm going to be moving this point 1, 2 to the left and 1, 2, 3 up. Okay, and now let's sketch it. So you're going to go over 1, up 1, over 2, that'd be up 4. So 1, 2, 3, 4. Over 2, 1, 2, 3, 4. And so my graph should look something like this. And so this is the graph of y equaling x plus 2 squared plus 3. The vertex is here at negative 2, positive 3. The axis of symmetry is just the line x equals negative 2. Let me do problem number 74. F of x equals negative x squared plus 1. And so I have that y is equal to negative x squared plus 1. Subtract 1 from both sides of your equation. So y minus 1 is equal to negative x squared. And so let's translate. This is just a translation of y equaling negative x squared. And you're just moving this up 1 unit. And, well, the graph of, let's multiply both sides of my equation by negative 1. So this is negative y equaling x squared. So this is a reflection of the graph y equal x squared. And this will be about the x-axis. Okay, so let's draw this. Oh, well, I guess I don't have any room to draw it at this second. So let me find the axis of symmetry. So in this case, the axis of symmetry is found by just letting, in this case, x equals 0. And the vertex will occur when x is 0. But when x is 0, y is just equal to 1. And now let me sketch the graph of this. Okay. Okay, so I have here the graph of y equal x squared. I then want to reflect this about the x-axis. So let's do that. And so I get the graph of y equaling negative x squared. And now let us translate up by 1 unit. So I'm going to move this up 1 unit. Okay, and so it's here at 1. Oh, I forgot to put the tick marks. I just sort of graphed this without any tick marks, so let me put the tick marks here. And so I'm going to go over 1, down 1. That looks somewhere around there. Over and then down 4. So over 2, down 4. 1, 2, 4. Okay, so about here and here. Okay, so it should look something like that? Yes. Oh, 4. Because here, let me draw this a little bit better. And maybe I will, because 1 squared is 1 and 2 squared is 4. So that's why I go over 1 and 4. But let me actually, instead of that, actually maybe even for both of these, what I'll do is I'll just set up an x and y. And so if you plug in, I guess for here, the x's are going to be, oh, let's do -3, -2, and -1. And actually, I did -4 to 0. -4, -3, -2, -1, 0. If I fill that in, I go -4 plus 2 is a -2 squared is 4, plus 3 is 7. -3 plus 2 is a -1 squared is 1, plus 3 is 4. -2 plus 2 is 0 squared, plus 3 is 3. -1 plus 2 is 1 squared, plus 3 is 4. 0 plus 2 is 2 squared is 4, plus 3 is 7. So what you notice here, and this always works as long as there's a 1 in front of the square term, if you go to the right and left 1, then you go up or down 1 depending on what's happening. And if you go over 2, then you go up 4. So that's why you add 4. Here, I'm actually doing a subtraction because there's a minus in front of the square. So if I fill in this x and y table here, and let's do, I guess I'm just doing -2 to +2. -2, 1, 0, 1, 2. So let me fill that in. A -2 squared is 4, and change the sign, so it's a -4, plus 1 is a -3. A -1 squared is 1, change the sign, so it's a -1 plus 1 is 0. 0 squared is 0, change the sign, but it's still 0, plus 1 is 1. 1 squared is 1, change the sign, so it's -1 plus 1 is 0. 2 squared is 4, change the sign, -4 plus 1 is -3. And so, notice, you start here at the vertex, you go over 1, and so I'm going to subtract 1, that gives me 0. Go over 2, subtract 4, that gives you -3. Okay? Did that answer your question? Maybe, yeah, okay. Let me do, so I mean, it may even be better just to plug in the x and y values. 75. F of x equals x squared plus 5x. G of x equals x plus 2. F composed, I should say this, F composed with G at 2. Well, that's what I want to figure out. So it says, for the given functions f and g, find the composition. So first, let's compute g of 2. So wherever I see an x, I replace x by 2. 2 plus 2 is 4. Now let's determine f at 4. Wherever I see an x in the formula for f, replace x by 4. And so 16 plus 20 is 36. Therefore, f composed with g at 2 same as f evaluated at g of 2. Well, g of 2 we found was 4. F of 4 we found was 36. So f composed with g at 2 is 36. Let me do problem number 75. No, 76. F of x equals, well, it's the same thing. X squared plus 5x. G of x equals x plus 2. Compute g composed with f at 4. So let's first compute f of 4. Well, we actually know what that is, but 36. So f of 4 is, wherever I see an x, I'll replace x by 4. And so 4 squared is 16, plus 20 is 36. Let's compute g of 36. 36 plus 2 is 38. Therefore, g composed with f at 4 is g evaluated at f of 4. F of 4 is 36. G of 36 is 38. Therefore, g composed with f at 4 is 38. Let me do problem number 77. F of x equals 6x squared minus 3x. G of x is negative 2x. I want to compute g composed with f at x. So wherever I see an x in the formula for g, I replace x by the formula given by f of x. So wherever I see an x in the formula for g, I replace f of x by 6x squared minus 3x. And so I have a negative 2 times x. I replace x by 6x squared minus 3x. Let me multiply the negative 2 inside the parentheses. And so I get negative 12 x squared plus 6x. And that is your answer. Let me do problem number 78. F of x equals 5x plus 12. G of x is 2x minus 1. Determine f composed with g at x. So wherever I see an x in the formula for f, I replace x by the formula given by g. So wherever I see an x here in the formula for f, I replace x by 2x minus 1. So I have 5 times x, 2x minus 1, plus 12. Let me multiply 5 inside the parentheses. So I get 10x minus 5 plus 12. And so f composed with g at x is just 10x. 12 minus 5 is 7. And that is your answer. Let me do problem number 79. 2x plus 7 equals 6. Solve the equation, give the exact solution. So, to solve this equation, let me take ln of both sides of my equation. By the property of the logarithm, I can bring the x plus 2 out in front of the logarithm. let me, oops, let me multiply ln2 inside the parentheses. And so I get x ln2 plus 7 ln2 equals ln6. Subtract 7 ln2 from both sides of my equation. So I get x ln2 is equal to ln6 minus 7 ln2. Let me divide both sides of my equation by ln2. And so I have that x is equal to ln6 minus 7 ln2 all divided by ln all divided by ln2. And that is your answer. Let me do problem number 80. E to the 3x is equal to 8. So let me solve this equation. Let me take ln of both sides of my equation. Since the logarithmic function is injective, is 1 to 1. ln e to any exponent is just that exponent, since ln and the exponential function base e are inverse functions of each other. And so ln e to the 3x is just 3x. Let me divide both sides of my equation by 3. And so x is equal to ln 8 over 3, which actually is ln of 2, but I'll leave it like this. So that's problem number 80. Actually, let me look at the answers, just in case she simplified to ln of 2. I doubt it, but just in case. 80, yeah, so that's the way she wrote it. Oh, she put a log there. Who cares? Okay, so let me do problem number 81. I noticed that on problem 79, she wrote the answer slightly different, but they're both the same answer. They're just written in different forms. Okay, so let me do problem number 81. E to the x plus 2 is equal to 4. Okay, so let me do that. Let me take ln of both sides of my equation. Again, ln e to the x plus 2 is just x plus 2. Since ln and e, the logarithmic function, natural logarithmic function, and the natural exponential function are both just inverse functions of each other. Let me subtract 2 from both sides of my equation. So x is equal to ln 4 minus 2. And that is your answer. Let me do problem number 82. Log 4 plus x log x minus 4 is log 3. Solve the equation. So, since the difference of logs is just the same as the log of the quotient, this is the same as log of, well, x plus 4 over x minus 4. equals log of 3. Since the logarithmic function is injective, then if these two logs are equal, then what's inside the logs must be equal. So x plus 4 over x minus 4 must equal 3. Multiply both sides of your equation by x minus 4. So I get that x plus 4 is equal to 3x minus 12. Add 12. Subtract x from both sides of your equation. So 16 equals 2x. Divide by 2. So x is equal to 8. Since when x is 8, 4 plus 8 is positive, 8 minus 4 is positive, 3 is positive, then yes, indeed, x equaling 8 is a solution. Recall that you have to check that you are taking the logs of positive numbers. You don't want to take the log of a non-positive number. That will not be defined. So logs of non-positive numbers are not defined. Let me do problem number 83. Log base 4 x squared minus 3x is equal to 1. So let me rewrite this logarithmic form in exponential form. So the base is 4, exponent is 1, and the result is x squared minus 3x. Let me subtract 4 from both sides of my equation. And so I get x squared minus 3x minus 4 is 0. This is a monic quadratic trinomial in x. So I can just put x's here, drop down to minus, times minus is plus. I want two whole numbers whose product is 4 and whose difference is 3. So 4 and 1. By the zero factor property, let me set each factor to 0 and solve for x. So add 4 to both sides of my equation. So x is equal to 4. Subtract 1 from both sides of my equation. So x equals negative 1. Well, let's see. The log of 4 squared is 16 minus 3 times 4, 12. Oh, that's 4. So that's a positive number. So I can certainly take the log of that. Let's plug in negative 1. Negative 1 squared is 1. Minus 3 times negative 1 is a plus 3. 1 plus 3 is 4. So again, that's positive. So I can take its log. So I have, in this case, two solutions. And so I have positive 4 and negative 1. So let's do problem number 84. Log base 4, 7 plus log base 4x equals 1. So, by the properties of logarithm, since the sum of logs is the same as the log of their product, then the log base 4 of 7 plus log base 4 of x is the same as log base 4 of 7x. Let's rewrite this in logarithmic form. Let's rewrite the logarithmic form in exponential form. So the base is 4, exponent is 1, result is 7x. Divide both sides of my equation by 7. So x is equal to 4 over 7. Since 7 is positive, I can take its log. Since 4 over 7 is positive, I can take its log. Therefore, My solution is x is 4 over 7. Let me do problem number 85. ln 8 plus ln x equals 0. Again, the sum of logs is the same as the log of the product. And so ln 8 plus ln x is the same as ln 8x. Let's rewrite this logarithmic form in exponential form. The base is e, exponent is 0, result is 8x. E to the 0 is 1. Divide both sides of my equation by 8. So x is equal to 1 over 8. Well, 8 is positive, so I can take the log of 8. 1/8 is positive, so I can take the natural logarithm of 1 over 8. And so x is equal to 1 over 8. Let me do problem number 86. Log base 5 x plus log base 5 x minus 24 is equal to 2. Okay, so the sum of logs is the same as the log of their product. So this is the same as log base 5. So let's multiply x times x minus 24. So x squared minus 24x equals 2. Let me write this logarithmic form as an exponential form. So the base is 5. The exponent is 2. The result is x squared minus 24x. So x squared minus 24x is equal to 25. 5 squared is 25. Subtract 25 from both sides of your equation. And so x squared minus 24x minus 25 is 0. This is a monic quadratic trinomial in x. So I'll bring down the x's. Bring down the minus, times minus is plus. I want two whole numbers whose product is 25 and whose difference is 24. 25 and 1. And write the larger absolute value root first. By the zero factor property, set each factor equal to 0 and solve for x. Let me add 25 to both sides of my equation. And so x is equal to 25. Subtract 1 from both sides of my equation. So x is equal to negative 1. Now let's check if these are not, determine that these are not extraneous solutions, because you do not want to take the logarithm of a non-positive quantity. And so, well, 25 is positive, so I can take the log of 25. 25 minus 24 is positive, so I can take the log of 1. Oops. And so x is equal to 25. Let's look at when x is negative 1. Well, log base 5 of negative 1, can't do that. So that's an extraneous solution. So let me get rid of that extraneous solution. So there's only one solution in this case. X is equal to 25. Let me do problem number 87. Log base 6 x plus 2 minus log base 6x is equal to 2. So again, the difference of logs is the same as the log of the quotient. So this is log base 6 of x plus 2 over x equaling 2. So let's rewrite this logarithmic form as an exponential form. The base is 6, exponent is 2, result is x plus 2 over x. And so 6 squared is 36. Multiply both sides of your equation by x. And so x plus 2 is 36x. Subtract x from both sides of your equation. And so 35x is equal to 2. Divide both sides of your equation by 35. So x is equal to 2 over 35. Well, 2 over 35 plus 2 is positive, and 2 over 35 is positive. So I can take the log of each of those. Therefore, x equaling 2 over 35 is a solution to my equation. Let me do problem number 88. Find out how long it will take a $2,700 investment to earn $1,000 interest. I'm sorry, $400 interest if is invested at 8% interest, which means that R, written as a decimal, is 0.08, compounded monthly. It says round to the nearest tenth of a year. Okay, so let's do that. So it says use the following formula. A equals P 1 plus R over N to the NT. Okay, so note that if the interest is $400, and if you started with $2,700, then the amount of money you have is what you start out with plus the interest. And so $3,100. So A here is 3,100. P is 2,700. R is 0.08. There are 12 months in a year, and I want to figure out what T is. So let me divide both sides of my equation by 2,700. So, well, I can divide both 3,100 and 2,700 by 100. So this is just 31 over 27 is equal to 1 plus. I can divide 0.08 divided by 12. So well, you can at least reduce that, divide by 4. And so, because it'll be in thirds, 0.02 over, 0.02 over 3 to the 12t. Maybe I'll leave it like that. Just dividing both 0.08 and 12 by 4, getting a common denominator. I can write this as 31 over 27 is equal to 3 plus 0.02, so 3.02 over 3 to the 12t. Well, let's try to solve that. let's take the log of both sides of this equation to try to solve for try to solve this exponential equation. So 3.02 over 3, the 12t. Take ln of both sides of my equation. And so I can bring the exponent out in front of the logarithm by the properties of log. So this is 12t ln of 3.02 over 3. Okay, so let's solve for t. So let's divide both sides of my equation by 12 ln of 3.02 over 3. So t is equal to ln 31 over 27 over 12 ln 3.02 over 3. And now let's get an approximate answer for that. So t is approximately ln 31 divided by 27 divided by 12 ln 3.02 over 3. And so I get 1.73262912 years, rounding to the nearest tenth. T is approximately 1.7 years. And so that's my approximate answer. Okay. And so let me do, I'm sorry, I just noticed Valley is going to be closed on Thursday. I just got an email. Okay. Please check, by the way, please check the Valley website after we're done with this. So no classes tomorrow. Problem number 89. Find out how long it takes a $3,500 investment. So you start out with $3,500 to double. So to become $7,000 if invested at 7%, written as a decimal, 0.07, compounded semi-annually. Round to the nearest tenth of a year. Okay, so let's do that. So I said round to the 10th. And so it says use the formula, the compound interest formula. A equals P, 1 plus R. Sorry, that R doesn't look like an R. 1 over R to the N to the NT. Okay, so let's do this. So A is 7,000. That's the amount of money you want. P is 3,500. That's how much you start out with. R is 0.07, and it's compounded semi-annually. So N is 2. you compound it twice a year, and I don't know what t is. Divide both sides of your equation by 3,500. And so 2 is equal to 1 plus, well, 0.07 divided by 2.035. And so let me add 1 to that. So I get 2 is equal to 1.035 to the 2t. So let's take ln of both sides of my equation. Let's take ln of both sides of my equation. There. And so I have that ln 2 is equal to bringing down the exponent out in front of the logarithm by the properties of the log. Now let's solve for t. So let me divide both sides of my equation by 2 ln 1.035. And so I have here that t is equal to ln 2 over 2 ln 1.035. Let us find the approximate answer. So let me do that on my calculator. So ln 2 over 2 ln 1.035 is 10.07439,584. So t is approximately 10.1 years, rounding to the nearest tenth of a year. So that is my answer. Let me do problem number 90. Okay. Find so I have here x minus 9 squared, y minus 6 squared is 49. Find the center and radius of the circle. So the center of the circle is 9, 6. The radius of my circle, square root of 49, is 7. Let me do problem number 91. X plus 2 squared plus y squared equals 36. So the center of my circle is -2, 0. And the radius, square root of 36, is 6. Let me do problem number 92. X squared plus y minus 9 squared equals 9. So the center of my circle is 0, 9. And the radius of my circle, square root of 9, is 3. Let me do problem number 93. X squared plus y squared minus 2y is 0. Sketch a graph of the equation. If the graph is a parabola, find its vertex. If the graph is a circle, find its center and radius. This is going to be a circle. So let's complete the square. Well, you don't have to do anything to the first guy. Well, actually, let me write this as follows. So let's complete the square. Since this term here, this y term here, is in the parentheses, is a monic quadratic. There's a 1 in front of the y squared. Then to complete the square, I'll just do -2 divided by 2, -1. -1 squared is +1. So let's add 1 to both sides of my equation. And so the center of my circle is 0, 1. And the radius of my circle is 1. Square root of 1 is 1. Oh, and so find center radius, and let's sketch the graph of this. So 1, 2, 1, 2. So the center is at 0, 1, and the radius is 1. So it should look something like this. Good enough. Okay. What? Well, that's sort of disappeared. Let's do it again. Okay, so that doesn't look that good. Let's do this again. Okay, so sorry about that. Let me, it keeps erasing on me, so let's do this. So there. So center, and you go out 1. So let's see. Good enough. So the radius is 1. I won't. Let me get rid of that. Okay, so that is the center and radius of your circle. Good enough. Those tick marks sort of died out towards the end. I'll just sort of say there. Okay, that looks a little bit better. Let me do problem number 94. Oh, another circle. X squared plus y squared minus 4x minus 8y plus 11 equals 0. Okay, so let's subtract 11 from both sides. So I get x squared minus 4x. I get y squared minus 8y equals -11. So let's complete the square for each of these. So since this is a monic, what's in the parentheses for the first parentheses is a monic quadratic trinomial in x. To complete the square, just take -4 divided by 2. -2 squared is 4. Add 4 to both sides. Again, in the second parentheses, for the y, that's also a quadratic, a monic quadratic trinomial, monic quadratic in y. So to complete the square, just take -8 divided by 2, -4, squared is 16. So let's add 16 to both sides of your equation. And so I get that the center is 2, 4, and their radius is 3. So let's see if I can draw this. It'll be a little bit bigger, and actually harder to draw since it's bigger, but okay, so let's see. Well, let's draw it over here. So 1, 2, 3, 4, 5, 6, 7, just barely. Okay, so 1, 2, 3, 4, 5, 6, 7, and that's y. 1, 2, 3, 4, 5. Okay, so the center is at 2, 4. 1, 2, 3, 4. So I'm going to go 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. See if I can do this. Okay. So 3. Okay, so let's yeah, whatever. Yeah, whatever. Okay, so I'll just there. Make these really big to sort of say I made them. Okay, so that is your circle. The radius here is 3. Okay, let me do problem 95. It's hard to draw with this tablet. 95. Okay, x squared plus y squared plus 8x plus 12y plus 48 equals 0. Okay, so it's another circle. So I have x squared plus 8x, grouping the x's and y's together. X squared plus 12y, y squared plus 12y equals, subtracting 48 from both sides of my equation, negative 48. And so let's complete the square. Since what's inside the parentheses is a monic quadratic, to complete the square, I'll just do 8 divided by 2, 4 squared, 16. Add 16 the other side of my equation. Again, since what's inside the parentheses is no way. What's inside the parentheses is is a monic quadratic. To complete the square, I'll just do 12 divided by 2, 6. Squared is 36. And so I have that the center is at negative 4, negative 6, and the radius is 2. And so let me try to draw this, if at all possible. Negative 6 and 2, okay. 1, 2, 3, 4, 5, 6. Okay, so about there. Okay, so let's draw this. Putting all my tick marks. Uh-oh. Have to go to 6. 1, 2, 3, 4, 5, 6. Okay, yeah. Okay, that's good. Okay, so the center is at -4. 1, 2, 1, 2, 3, 4. 1, 2, 4, 5, 6. Here's my center. I have a radius of 2, so 1, 2, 1, 2, 1, 2, 1, 2. Actually, that's a little off. And let's draw the circle. Good enough. So this, there, so you don't see how that smudges. And so this is the center, and the radius is 2. 96. So problem number 96. 9 x squared 25y squared equals 225. So let me divide both sides of my equation by 225. And so I have x squared over 25 y squared over 9 is equal to 1. So this is going to be an ellipse centered at, so this is an ellipse, and the center is at the origin. A is 5, B is 3. I can figure out C also, but C is 25 minus 9 is 16, square root of 16 is 4. And so the vertices are at plus or minus 5, 0, 0, plus or minus 3. And the foci, but you really don't need that. I'm not going to write the foci. I'll just leave it like this. You could figure out the foci, but I'm only graphing, so I don't think they will require that, so I won't write it. Okay, so let me sketch the graph of this. Five. 1, 1, 2, 3, 4, 5. 2, 3, 4, 5. Ooh. Okay. 1, 1, 2, 3, 4, 5. 1, 2, 3, 4. Oops. 5, 2, 3, 4. 5. 1, 2, 3. 3. Okay. Ooh. It's in the other direction. 1, 2, 3, 4, 5. 4, 5. Okay, so I go 5 in the X, 3 in the Y. And so my ellipse should look something like, if I can draw this, not too bad. Okay. And so the center is at the origin. And so you have here 5 and 3. And those are your vertices and your center. Let me do problem number 97. Two x squared, 25x squared plus 16y squared is 400. So let me divide both sides of my equation by 400. And so I have x squared over 16 plus y squared over 25 is equal to 1. So again, this is an ellipse. The center of my ellipse is at the origin. A is 4, B is 5, and C is going to be 3, but I don't care. The vertices are at plus or minus 4, 0, 0, plus or minus 5. So let's sketch the graph of this. So I got to go 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so that should be enough. Okay, so 2, 3, 4, 5. So right there. Okay, so 4. 1, 2, 3, 4. 1, 2, 3, 4. 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it should look something like, yeah, whatever. Okay, so here. Now actually, in this case, it looks like it's wider than thinner. Okay, it's taller than it is wide. So that didn't look good enough for me. So I'm going to redraw it if I can. Okay, so let's do this again. See if I can get it looking better. 1, 3, 4, 5. 1, 2, 3, 4, 5. Let me see if I can get it. 1, 2, 3, 4. 1, 2, 3, 4. That's a little. Even there, it's a little. I'm going a little bit further. Okay, so it should look something like. Not too bad there. Okay, it's looking a little bit better at least. So the center is at the origin. You go 4 in the x, 5 in the y. Let me do problem number 98. X squared plus 25 y squared equals 25. Let me divide both sides of my equation by 25. So I get x squared over 25 plus y squared over 1 equals 1. So in this case, it's an ellipse. The center is at the origin. A is 5. B is 1. Okay, at least that's better. And so I have the following. So let's see, 1, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it looks something like, shoot. Okay, let's try that again. Good enough. So there, there, there. So at 5 and at 1. Oh, so the vertices are at plus or minus 5, 0, and 0 plus or minus 1. So those are the vertices, and here's the center at the origin. Let me do problem number 99. X minus 2 squared over 16, y plus 2 squared over 9 equals 1. So this is a ellipse. The center in this case is 2, negative 2. A is 4. B is 3. And so the vertices will be at 2 plus or minus 4, negative 2, and at 2, negative 2 plus or minus 3. So let me list the vertices. So vertices are at negative 2, negative 2. 2 plus 4 is 6, negative 2. Negative 2 minus 3 is a negative 5. And negative 2 plus 3 is 1. And so let's do this. So 1, 2, 1, 2, 3, 4, 5. Okay, so I have here that the center is at 2, 1, 2, negative 2. And so I go 4 in the x, so 1, 2, 3, 4. 1, 2, 3, 4 in the x. And 3 in the y. So 1, 2, 3. 1, 2, 3. And this is my ellipse, as best I can draw it. And so this is the center at 2, negative 2. And these are my 4 vertices. Okay, let me do problem 100. X minus 2 squared over 4, y plus 2 squared over 9 equals 1. Okay, so again, this is an ellipse. The center is at 2, negative 2. A is 2. B is 3. C would be the square root of 5. The vertices are at 2 plus or minus 2, negative 2. And at 2, negative 2 plus or minus 3. And so those are at 2 minus 2 is 0, negative 2. 2 plus 2 is 4, negative 2. Negative 2 minus 3 is a negative 5. Negative 2 plus 3 is 1. And so let me do this. The center is at 2, negative 2. Okay. So 1, 2, negative 2. So that's the center of my ellipse. And I go 2 in the x. So 1, 2 in the x. 1, 2 in the x. And I go 3 in the y. So 1, 2, 3. 1, 2, 3. And this, let's see if I can draw this. Let's start. No, no, no. That's horrible. That's still semi-horrible, but not so bad. Okay, so this is my ellipse with center at 2, negative 2. So this is going to be 4. That's a negative 2. That's 2. And that's 5. And that's a 1. Okay. And those are my vertices of my ellipse. 101. 16 x squared minus 4 y squared equals 64. Divide both sides of my equation by 64. And so I get x squared over 4 minus y squared over 16 is equal to 1. This is a hyperbola. The center of my hyperbola is the origin. A is 2. B is 4. C would be the square root of 20, 2 rad 5. The vertex, well, and let's draw this if I can. As best I can. Okay, so 4 in the x, 2 in the x. 1, 2, 1, 2, 1, 2, 3, 4, 2, 3, 4 in the y. Let me draw the bounding rectangle. Let me try to draw the asymptote. Let's draw another asymptote. Okay. And so the x is positive. Therefore, the vertices are located here at plus or minus 2, 0. And the foci are also located here at plus or minus, what is it? That's 2 rad 5. And the hyperbola looks something like this. trying to draw it as best I can. That actually doesn't look too horrible. And not too horrible. Not great, but it's the best I can do with being on a tablet. Okay, so that's my hyperbola. Let me do 102. Oh, and the asymptotes are just y equals plus or minus 2x. 102. Oh, x squared plus y squared is 41. X plus y equals 9. Okay, so let's actually try to solve our 2 for y. So let's subtract x from both sides of my equation. Okay, it didn't change color. Let's subtract x from both sides of my equation. So y is equal to 9 minus x. Now let's, maybe I'll just call this S1. Now let me substitute S1 into R1. So if I do that, I'll get x squared plus y, which is 9 minus x squared, equals 41. So I get x squared plus 81 minus 18x plus x squared is 41 by the special product, using the special product formula. Combine like terms, so I get 2x squared minus 18x plus 81 is equal to 41. Let me subtract 41 from both sides of my equation. So I have 2x squared minus 18x plus 40 equals 0. So let me divide both sides of my equation by 2. And so I have x squared minus 9x plus 20 is 0. Let me factor this. This factors into x minus 5, x minus 4 equals 0. So this is a monic quadratic trinomial in x. So I put x's here. I have a minus, so I'll bring down the minus times plus is minus. I want two whole numbers whose product is 20 and whose sum is 9, so 5 and 4. And I put the larger absolute value root first. Set each factor to 0 and solve for x. So add 5 to both sides of my equation. So x is equal to 5. Add 4 to both sides of my equation. So x is equal to 4. Well, oops. Using S1, 9 minus x. I get y is equal to 9 minus x. Y is equal to 9 minus x. And so I have two solutions, 5, 4, and 4, 5. Okay, so let me do problem 103. x squared plus y squared equals 58. 7x plus 3y equals 0. So, let's solve for y, I guess. Subtract 7x from both sides of my equation. So 3y equals negative 7x. Divide both sides of my equation by 3. And so y equals negative 7/3 x. Let me call that S1. So now let me plug S1 into R1. So I get x squared plus y squared equals 58. Okay, so let me just multiply both, let me square. And so this is x squared plus negative 7 squared is 49. 3 squared is 9. Let me multiply both sides of my equation by 9 to get rid of the denominator. And so I get 9x squared plus 49x squared is equal to 9 times 58, 522. And so 58 x squared equals 522. Divide both sides of your equation by 58. So x squared is equal to 9. And so x is equal to plus or minus 3. And so this says that by S1, I have that y is equal to negative 7/3 x. And so I get minus or plus 7. So my solution is when x is negative 3, y is positive 7. And when x is positive 3, y is negative 7. Okay. Notice that x and y are going to have opposite signs because of this negative here. Okay, let me do problem number 104. Find the indicated term. Oh, I didn't even read the question for the above problems. For the previous problems, it said solve the nonlinear system of equations for real solutions. Luckily, they only had real solutions. Find the indicated term of the sequence. So the 8th term of an arithmetic sequence whose first term is negative 10 and whose common difference is negative 2. Well, I know that the general term for arithmetic sequence is just a1 plus n minus 1d. Therefore, the 8th term is just a1, negative 10, plus n, 8 minus 1d, negative 2. And so I get a negative 10 plus 7 times negative 2 So negative 10 minus 14 is negative 24. So the 8th term in this sequence is negative 24. Let me do problem 105. Find the 11th term of the arithmetic sequence. Whose first term is negative 4, and whose common difference is negative 6. So again, the general term is just a1 plus n minus 1d. And so the 11th term is just a sub 1 plus n minus 1d. So negative 4 plus 10 times negative 6. Negative 4 minus 60 is a negative 64. Let me do 106. The 12th term of negative 5, 1, 7, and this is an arithmetic sequence. Okay, so let's find the 12th term of that arithmetic sequence. Well, again, a sub n, a1 plus n minus 1d. The first term is negative 5. So a sub 1 is negative 5 plus n, 12 minus 1d. Well, the common difference, well, I keep adding 6 to get to the next term. And so a negative 5 plus 11 times 6. And so negative 5 plus 66 is 61. So the 12th term in this sequence is 61. Problem number 107. If the 13th term of an arithmetic sequence is 13, so arithmetic sequence, and the 17th term is 21, find the third term. Okay. So, again, I know the formula for the general term of an arithmetic sequence. And so, a sub n is equal to a sub 1 plus n minus 1d. And so, I know that the 13th term is equal to 13. So, I don't know the first term, but I know n is 13, and I don't know the common difference. So this says that a1 plus 12d is 13. Similarly, I know that the 17th term is 21. I don't know the first term, but I know it's the 17th term in the sequence. And so I know that a1 plus 16d is 21. Okay, so let's just subtract these. So I'll just do a1 plus 16d is 21, and let's subtract a1 minus 12d equaling negative 13. The a1's cancel, and so you get 4d is 8 divided by 4. So d is 2. Let's plug this into this first equation here. So I have that A1 plus 12D is 13. And so I have that A1 plus 24 is 13. Subtract 24 from both sides of my equation. So A1 is equal to a negative 11. And so let's figure out the third. So I know that A sub n, well, let's figure out the third term. And so the third term is equal to A sub 1 plus n, 3, minus 1d, which was 2. And so negative 11 plus 2 times 2. So A sub 3 is negative 7. Okay, so, whoops. Okay, so sorry about that. Let's do problem number 108. Oh. Last page. Wow, that was fast. So, problem number 108. If the second term in an arithmetic progression, so arithmetic sequence, arithmetic progression is just the term you used in grade school for arithmetic sequence, is negative 9, and the 10th term is 31. Find the 17th term. Okay, so let's do that. So I have that the general term for arithmetic sequence is just the a sub 1 plus n minus 1d. And so I don't know a1, plus let's say that we're looking at the second term. The second term is equal to negative 9. Let's say that we're looking at the 10th term. The 10th term is 31. And so I have that a1 plus 9d is 31. Let's call that R1. And I have that a1 plus d is a negative 9. So let's just subtract these. So R1, a1 plus 9d is 31, minus R2, minus a1, minus d is 9. Therefore, 8d is 40. Divide both sides of your equation by 8. Shoot. Divide both sides of your equation by 8. So A is 5. Why did I say A? And so D is 5. I don't know what A came from. And so let's figure out. Maybe I'll plug into R2. So I have A1 plus D is negative 9. Subtract 5 from both sides of my equation. So A sub 1 is negative 14. Okay, and I want to figure out the 17th term. 17th term. So let's figure out the 17th term. So it's A sub 1 plus n minus 1d. So negative 14 plus 16 times 5. So negative 14 plus 80. And so the 17th term of the sequence is 66. Let me do problem number 109. The sixth term of a geometric sequence whose first term is 2 and whose common ratio is 4. Okay. And so I know that the general term for geometric sequence is just a sub 1 r to the n minus 1. And so to find the sixth term, I have a sub 1, 2, r, 4 to the n, 6 minus 1. And so this is just equal to 2 times 4 to the power 5, which is 2 times 1024. And so a sub 6 is equal to 2048. And that's the sixth term in my sequence. Let me do problem 110. Find the fifth term of a geometric sequence whose first term is 6 and whose common ratio is negative 4. Okay, well, I know that a sub n is equal to a sub 1 r to the n minus 1. That's the formula for the general term of a geometric sequence. And so, to find the fifth term, I have a sub 1, 6, times r, negative 4, to the power n, 5 minus 1. And so, this is equal to 6 times a negative 4 to the fourth, which is equal to 256. And so I get 1,536. Okay. Let me do problem number 111. Okay. Evaluate the expression. Sum I equal 2 to 5 of 3i minus 2. Okay, so first let's substitute for I2, for I3, for I4, for I5, and so you get 6 minus 2, 9 minus 2, 12 minus 2, 15 minus 2. So I'm adding 4 plus 7 plus 10 plus 13, which is equal to 34. Problem 112. Add I equaling 1 to 3 to 5 of I squared minus 4. So this is equal to, so first plug in 3, then plug in 4, and lastly plug in 5. Since it says that you want to go from I equaling 3 to I equaling 5. So you just want those terms. So this is equal to 9 minus 4, 16 minus 4, 25 minus 4, and so 5 plus 12 plus 21 is 38. Problem 113. Sum I equaling 2 to 4, I minus 5. So this is equal to 2 times 2 minus 5 plus 3 minus 5 plus 4 minus 5 by plugging in for I 2, 3, and 4. So it starts at 2 and ends at 4. So let's compute this. So this is 2 times negative 3, 3 times negative 2, 4 times negative 1, negative 6, negative 6, negative 4, negative 16. Let me do 114. Wow, okay. So sum I equaling 1 to 4 of 2 to the I. So you plug in 1, 2, 3, and finally 4. And so this is equal to 2, 4, 8, 16. So if you add those all up, you get 30. And that is actually it. That was the last problem. Wow, I know. Ooh, wait, why'd you? Oh, yeah, that was, I answered that. Okay, any questions about anything? By the way, please check your email and please check the Valley website. Please note that there are no classes at Valley tomorrow. Okay? Please keep looking at the Valley website to see what's happening with all the fires. Okay? To keep yourself up to date on the fires. Okay. Okay, so I guess that's it. And well, I guess I won't be seeing you guys, but good luck on your final.